This is critical thinking in the urinary physiology lab, and in this lab you'll be using your Physio XCD, but you must be very careful that you understand what exactly you're doing and how you apply this to the physiological processes. So here I have 3 questions to help you understand that. So this is the first one. Here is the second one. And here is the third one. So let's look at this first question, which asks you the effect on glomerular filtration rate if the efferent arteriole were constricted. So let's look at the Bowman's capsule and the afferent arteriole, which normally has a wider diameter than the efferent arteriole. And the idea is so that blood flows in easily, goes into the glomerulus, takes a while to get out, so it sets up a pressure here, the hydrostatic pressure, which is responsible for filtration. Now, if you constrict the efferent arteriole even more than it is already constricted, obviously the pressure buildup will be even more. So therefore, the filtration would increase, the glomerular filtration rate would increase. So the correct answer is the first one, which is that the glomerular filtration rate would increase. On the other hand, you can understand if you constrict the afferent arteriole. So if you make the afferent arteriole narrower, so you make this narrow, then blood will flow, less blood will flow in, and hence the pressure will be less. So there the glomerular filtration rate would decrease. So this is very important for you to understand. So you can see that, and you can compare this to a hose as I give the example. So if this is one end of the hose and you narrow this exit through the hose, you can see that there would be backup in this area, so the pressure would increase, which means more filtration would occur. On the other hand, if you take the same hose, so this is the input and this is the output. So you can see if this is narrow, pressure builds up because it's difficult to go out, so therefore filtration would increase. Whereas if you narrow the input too, so you can see less would go in, so hence the pressure would be less and filtration would decrease. So that's the example I give when we use the hose. Now let's look at the next question, where it asks if you wanted to produce concentrated and low volume urine, which of the following hormones would not be secreted? So here you're looking at the action of hormones on the DCT, on the distal convoluted tubule and the collecting ducts. So you're looking at the action of the hormones on the distal convoluted tubules and the collecting ducts. So the distal convoluted tubules and the collecting ducts. So here let's look at which hormone will not be secreted in order to produce concentrated and low volume urine. Concentrated and low volume urine will be produced when there is increased reabsorption of water at the distal convoluted tubule and collecting duct. So which means less water will pass out in the urine, so the urine will be low volume, so there'll be low volume, and hence it will be concentrated. ADH will be secreted when you want to produce low volume urine, because a function of ADH is to make the distal convoluted tubules and the collecting ducts permeable to water. So when they become permeable to water, water is reabsorbed, less is passed out into the ducts and out through as urine. So urine produced is low volume. Aldosterone acts pretty much in the same manner, because it causes reabsorption of sodium at the distal convoluted tubules and collecting ducts, and along with sodium there is reabsorption of water. Now the reabsorption of water is less than it is in ADH, but it still causes reabsorption of some amount of water, hence the volume of urine is much less than would be if aldosterone was not present. ANP, this is an antagonist of ADH and aldosterone. What it does is it acts on the distal convoluted tubules and the collecting ducts and causes sodium and water not to be reabsorbed. In other words, sodium and water are passed out into the tubules and out as urine. So it prevents the reabsorption of sodium and water. So they pass out in the urine. So you have copious amounts of urine. So the urine amount is more. So here we want less urine to be formed. So ANP is the hormone which will not be secreted. So you must know the actions of these hormones. So ANP is the answer to this question. Obviously it is not this or this. So that's the answer to this question. Now let's look at this question where it asks you what is the body's response to metabolic acidosis. So let's see what happens in metabolic acidosis. Here the tissues are metabolizing excessively. So they are producing more carbon dioxide. That more carbon dioxide will interact with water. And if you look at this equation, it will give rise to carbonic acid, which then breaks up into hydrogen ions plus bicarbonate ions. Now, because of excess carbon dioxide, the buffer system can only mop up so many hydrogen ions. So there is an excess of hydrogen ions because there's more of carbon dioxide. So free hydrogen ion concentration increases. So in metabolic acidosis, what you have is there is an increase in carbon dioxide, and that decreases the pH. So it makes it acidic. Now, what the body has to do to compensate is either get rid of the carbon dioxide, which can be done by the respiratory system, or so that means as you remove it as fast as you're making it, or this excess of free hydrogen ions which are present, the kidneys, what they can do is they can secrete the hydrogen ions into the tubule, and then that can be removed in the urine. So the hydrogen ions pass into the urine. So let's look at the choices and see which one is the correct one. So the first one, which says respiratory rate decreases. Now this is wrong because, as we said, to remove it, you want to remove carbon dioxide. The way the respiratory system can remove carbon dioxide is if the respiratory rate increases. And if you look at the second part of the question, even that is wrong. As I said, the kidneys can help by removing hydrogen ions in the urine. They can secrete hydrogen ions into the tubule. So if they are removed from the body, there'll be less and the pH can come back to normal. So both choices are wrong in this first statement. In the second statement, the first choice is wrong, but the second one is correct, but therefore the whole answer is not correct. In the third statement, respiratory rate increases. This part is correct, but again, you can see you don't want to secrete bicarbonate in the urine. Instead, you want to reabsorb bicarbonate. And if you look at the last choice, this is the correct one because here you're increasing the respiratory rate. So when you increase the respiratory rate, you remove more carbon dioxide and you also secrete hydrogen ions in the urine. The difference being that the kidney takes a longer time to compensate, whereas the respiratory system can do it early. So this is the answer to this question.